For the week 2 discussion, there's two options. For option 1, you're going to use the data set and you're going to create 4 samples of different sizes. You're going to use Excel to make histograms based off of those samples. So use one of these variables. They have some good values to work with. EMXP, TPCP, EMXT. If you use one of those 3, it really doesn't matter which one you use. We're going to see the same result or something pretty similar. So construct those histograms and just talk a little bit about how you see that shape changing as the sample size increases. For option 2, we are flipping a coin. And first we're going to flip it just 10 times and compare how many heads and tails we have. So you could have something like 7 heads and 3 tails, which would be 70% heads. Or you could have 6 heads and 4 tails, which would be 60% heads. After you do those 10 flips, you do 20 more flips. So now you have a sample of size 30. So combine the first 10 with your next 20. Again, look at how many heads and tails you have and see what percentage heads you have. Compare that to when you just had 10 flips. And then you're going to flip it 70 more times, so you have a total of 100 flips. So combine these 70 with the previous 30 for all 100. So now look at how many heads you have and see what percentage that is and compare it back to your sample of size 30 and sample of size 10. And then talk about how far away you are from that 50-50 split on each of your 3 samples, and do you notice a trend as your sample size is increasing? Notice that for any sample size, we would expect it to be 50% heads, 50% tails, because the coin has equal odds of landing on either side. But I think we'll see as we look through this discussion this week that that's not going to be the case for everybody, for every size sample they have. So now I'm going to end by showing you in Excel kind of a quick way to simulate coin flips if you want to do that. So we can use Excel as a random number generator, and the formula is going to be equals rand between and then 0, 1. And what Excel is going to do then is randomly produce a number, either 0 or 1. And so there's 2 options here. They each have an equal chance of being produced, so they each have a 50-50 chance. So it's just like a coin flip as far as odds go. So you could pick 0 to be heads and 1 to be tails, and then whenever Excel gives you a number back, we say, okay, we have a heads here on the first flip. And so you could drag that down, and for 10 flips now, I have tails, heads, etc. So that's how you can use Excel to quickly generate a large number of 50-50 odd scenarios, like a coin flip. Now, if you want to use a function to quickly add up how many you have, so equals sum of these, this is going to add up all the ones and tell me how many ones I have, which would be how many tails I have. Now, Excel will redo the random number generator every time you enter something new. So you notice all these numbers changed. It was just a new random generation. So I would look at this. I would say I had, for my sample of size 10, I had 80% tails. And I know it's changing every time I entered something, but I just going off that first value. So then you could drag all the way down. You want a total number of 30 for your second sample. And so I'm going to sum now all the way down all those 30. And this is okay that the numbers are going to regenerate each time. That's fine. So with 30, I have 14 tails showing up, which means our percentage here would be 14 out of 30. So 47%. And then finally, I could drag down till I had a sample of size 100. Went a little bit too far here. and Excel generates 100 random numbers. And I'm just going to type in A1 through A100. And I see now I have 49 tails. So 49 out of 100 would be 49%. So just from memory, I had 80% with a group of 10, 47% with a group of 30, and then I ended up with 49% when I had a group of size 100. So look at your own numbers from either manually flipping the coin or using Excel, and then talk about what you notice with the percentage as we get a larger and larger sample size. And maybe even project a little bit. What would you expect if you had a sample of size 1,000 or 10,000 or 1,000,000? What would you expect these percentages to do as far as the percent heads and tails? Would they get closer to certain values?